Theorem of Calculus. It might look scary, but I promise it's easier than you think. So watch the video, I'll teach you how. Be sure to subscribe and share the video with another calculus friend. The first fundamental theorem of calculus. It looks a little scary, but I'm going to read you the definition first, and then I'm going to explain what every part means. Here we go. The first fundamental theorem of calculus. If f is continuous on an interval a, b, and if capital Fx is the antiderivative of lowercase f on the interval a, b, then this integral mess equals that capital F of b minus capital F of a. And you're like, great! What does that mean? Okay, so let me tell you. It means if f is continuous, meaning this function right here, if it is continuous on our interval a to b, then f of x, that's this piece, is your antiderivative, meaning it's your answer. And once you get your answer, all you're going to do is plug in the b value and plug in the a value. So you actually get a numerical answer. It's not just going to have a plus c at the end anymore. You're actually going to get a numerical answer. So let me show you how we do that. Here's our example. The first thing you have to do is take the integral or find the antiderivative of this problem. So what we're going to do here, you're going to add an exponent and put 1 over that new exponent here. Plus 4 is going to get an exponent. Now usually here is where we add that plus c. We're not going to do that this time. Now we're going to do a bar like this. This means evaluate from 0 to 2. So the first thing we did is found the antiderivative. Now we're going to do this part here, f of b minus f of a, where we plug those values in. So equals 1/3 x cubed. 1/3. Now the x, I'm plugging in my x value. 2 cubed plus 4 times x. Plus 4 times my x value here is still 2. Right? Now notice, this says minus. So it's minus, you have to put a big old parenthesis over there because you're subtracting this whole function now with the second value in it. So now we have 1/3. Now my x value is now this 0. I'm going to plug him in. 0 cubed plus 4 times 0. Well, this just worked out nicely, didn't it? Because anytime you multiply by 0, what's going to happen to that piece over there? All that's going bye-bye. This piece here is a bunch of zeros, so this comes to be 0. And now we're just going to evaluate the part that we have in blue for our answer. So now we're left with 1/3. 2 cubed is 8 plus 8 over here. This becomes 8 over 3 plus 8. And if you think about it, 8/3, 3 goes in there 2 times with 2 left over. So you have 2 2/3 plus 8. So you have 10 2/3. And that's how you do the first fundamental theorem of calculus. See? Not so bad. Let's try some more. So let's try another problem. The first thing that we have to do is we have to integrate this thing. So when you integrate, you get 1/2 x squared evaluated from -3 to 3. Now we plug in. You plug in your top x value first. So I'm plugging him in here. 3 squared minus, there's only one piece to this function. So you can start with a big old parenthesis there. In this case, you don't really have to. 1/2, and then you put your -3 in here and square it. This equals 1/2 times 9 minus 1/2 times, well, -3 squared is 9. So a positive 9/2 minus 9/2 gives you a big fat 0. And there you go. Now you may be wondering, why all this work for 0? Let me show you quick what this function looks like. So if I were to draw this function, that's a rough sketch of 1/2 x squared, correct? So if I look at my values from -3 to +3, this whole piece right here and this whole piece right here are the same area. As you can see, the area under the curve for both of those sides are exactly the same. So you're taking one side and subtracting the other side. So both areas under the curve are exactly the same, and you subtract them out, and that's why you get 0. You don't have to graph all of these functions, but I want to show you why sometimes you will get 0, because it might just come up again. Let's try this one, because this one doesn't look as pretty. So first thing I'm going to do is I'm going to rewrite this problem. And this right here I'm going to think about is really x to the 1/2. And when you're multiplying x's, you add their exponents. So this is really 2x, this is exponent of 1, so 1 plus 1/2 is 1/2, or 3/2 dx. So the first thing you're going to want to do is simplify the function that is next to the integral. Now we're going to integrate. Okay, so let's remember a couple things when we integrate this. First of all, that 2 is going to come down with it. So I'm going to put the 2 here. Then we're going to add an exponent and put 1 over that new exponent out front. So I'm going to set up 1 over my new exponent and x. And now I have a new exponent. I have to add 1 to 3/2. So when I add 1 to that, this becomes 5/2. And this is 1 over 5/2. And then I'm evaluating. If you're evaluating, you got to put that bar, otherwise you have to put that plus c. 4 to 9. Now we're going to simplify. We have 2. This guy, if he's on the bottom, he flips over. X to the 5/2, evaluated from 4 to 9. So this is going to become 4/5 x to the 5/2, evaluated from 4 to 9. Now we can go ahead and plug in our x values. So first thing we have is 4/5. 9 comes in here first to the 5/2 power minus 4/5. This time x is 4 to the 5/2 power. I'm going to rewrite this as a square root to make this easier to solve. Or if you're allowed to use your calculator, stick this into your calculator. But if not, you've got 4/5. Now, this is really the square root of 9 to the 5th power. That's how this works. This denominator becomes your root. It's a square root. And my numerator stays as an exponent on the outside. And I'm doing this because I know that the square root of 9 is easy to find. That's just 3. And it's much easier to do 3 to the 5th. Minus, so same thing over here, 4/5. I'm going to do the square root of 4 to the 5th power. Minus, so now I'm going to simplify this. This becomes 2 to the 5th power. So now we're just going to simplify. 4 to the 5th. 3 to the 5th is 243. Minus 4/5. 2 to the 5th is 32. Whoops, squeeze that 2 in there. At this point, if you haven't pulled out your calculator, I would. You'll get a fraction of 844 over 5, or that simplifies down to 168.8. And there you go. Can you see how a lot of calculus is just a lot of messy algebra? But you got this. Of course! Trig, right? Because what would be calculus without trigonometry? So again, first thing we have to do is we have to integrate this. What did you take the derivative of to get cosine? Hopefully you're all like, sine. Sine of x evaluated from 0 to pi. You know what we're going to do, right? Here's our coordinates. Here's 0, here's pi. What are my ordered pairs? 1, 0, and -1, 0. So now we just plug in sine of pi minus sine of 0. And sine, of course, if you remember, is your y value over here. Shoop. And guess what? You're going to have 0 minus 0. So a whole lot of 0. Done. The one thing that you have to be careful about is any time that your function has a corner, because we all know that you cannot take the derivative of a corner, and an integral is the opposite of a derivative. And a derivative, if you remember, is a slope. A slope needs 2 points. That's why you can't take the derivative of a corner. So anytime you come across a corner, you have to figure out where that corner is, like where the function bottoms out, and you have to split the bounds, so that way we can take away the absolute value symbol. So we know with an absolute value graph that this function is a v, right? And it bottoms out or has its point when x is 0. So that's where we're going to split our bounds. But you have to remember, when we split those bounds, everything to the left of 0 is going to be a negative x value. So we're going to have -1 to 0 of negative x dx plus 0 to 2 of x dx. And now we'll just integrate like normal and plug in our bounds. -1/2 x squared evaluated from -1 to 0 plus 1/2 x squared evaluated from 0 to 2. Now I'm going to go ahead and plug in. This top bound is 0, so that whole piece is going to fall out, right? I'm going to write it in so you can see it. Minus, now we're subtracting away the other piece. And that's another reason why I wrote this in. Because some people might just say, oh, that's 0, that's going to drop away. But notice it's minus a -1/2, so you don't want to forget about that negative sign. And this is -1 squared. Plus, now on this side, we have 1/2 2 squared minus 1/2 0 squared. So again, that piece drops. Negative times a negative gives you a positive, and -1 squared is positive. So we have a positive 1/2 here. Plus, 2 squared is 4. 4 divided by 2 is 2. Minus, and that whole piece drops out, and that's 0. So we have 2.5 as our final answer. One other thing that goes really nice with the first fundamental theorem of calculus is the average value. So let's talk about this real quick. Basic math. How do you find the average of something? You add up all of the pieces and divide by how many total pieces you had, right? Pretty simple. Check this out. To find the average value in calculus, you just use a fancy way of adding things up. This right here is your integral, your summation. This is how you're summing up. This is how you're adding everything up. And then over here is where you're dividing by the total number of pieces you added up. So it's still finding the average, adding things up, dividing by the total number of pieces you had. But now you're just doing a cool form of it because you know calculus. Let's try this function. You have the function f of x is 3x on this interval from 1 to 3, and you want to find out the average value of this function. So the first thing you do, because you're a smart calculus student, is you add things up. I'm going to add up all of my function of 3x. Remember your triangles, base, height, you got to have all that. And you're adding it up from 1 to 3. But then you're going to divide by the total number of pieces you added up. So you have 1/2 out front. Let's integrate this thing. The 3 stays. Your x, you add an exponent and put 1 over that exponent out front. And then you're going to evaluate him from 1 to 3. So now as we simplify this mess right here, we have 3/4 x, and I'm putting in my x value, 3 squared minus 3/4. X is 1 squared. 3 squared is 9. 9 times 3 is 27. 27/4 minus 3/4. 24/4. So you have 6. Let's try this one. Again, finding the average value. You're going to sum up all that stuff. I'm going to sum up my x squared from -1 to 2. After you add them up, you have to divide by the number of pieces you added up. This part is easy to forget because I just forgot it. It's 1 over 2 minus a -1. You cannot forget to divide by how many total pieces you added up. That's how you find an average. Remember that. Just think through. How do I normally find the average of something? Just walk it through common sense wise and you can do it. So your function out front, you're going to have the 1/3 from this right here. Now we're going to integrate x squared, which is also going to give you another 1/3 because you added an exponent. Now we're evaluating from -1 to 2. So we have 1/9 out front, plugging my x values, 2 cubed minus 1/9 -1 cubed. All right, 2 cubed is 8, so we have 8/9 minus, now, -1 cubed is a -1. Negative times a negative is a positive. That's still going to be 1/9. Oh, check that out. 9/9. A whole big fat 1 for your average. Well, of course we have to have a trig problem, right? What is calculus without a trig problem? So again, the first thing we're going to do is integrate. What did you take the derivative of to get cosine x? Sin x. Very good. So again, we're adding up all of the parts of this function, and we're going to divide by, so we went from pi over 4 to negative pi over 4. So minus a negative pi over 4. Right? Again, don't forget to divide by how many you're adding up. This is going to become 1 over pi over 4 plus pi over 4 becomes pi over 2. When you integrate cosine, you get sine x evaluated from negative pi over 4 to pi over 4. So the first thing we're going to do is flip that fraction. So you're going to have 2 over pi, right? Sine of pi over 4 minus 2 over pi of sine of negative pi over 4. Hopefully you know what that means. Triangles are in your future. Here's our triangles, right? Our 1, 1, square root of 2. That's our pi over 4. And then down here is your negative pi over 4. So -1 square root of 2. Now we want our sine value of pi over 4. So sine is going to be 1 over the square root of 2. But negative pi over 4 is going to give us negative square root of 2. We'll have 2 over pi times 1 over the square root of 2 minus 2 over pi times -1 over the square root of 2. Which is kind of nice because this then becomes a positive. So we're adding them together. So this is 2 square root of 2 pi plus 2 square root of 2 pi, which is 4 square root of 2 pi. But you know, like leaving a square root in the bottom is not mathematically acceptable. So we're going to have to do something about that too. 4 square root of 2 pi. So I'm going to rewrite this because we have to get rid of that square root in the bottom because it's just mathematically not a good idea. So we're going to have to multiply by square root of 2 over square root of 2 to get rid of this guy in the denominator. So now you've got 4 square root of 2 over square root times the square root, that sucker's going to drop, 2 pi. That's nice. Those will simplify. You're going to be left with 2 square root of 2 over pi. And that, my friends, means you're done. Woohoo! We're out.